Assalamualaikum and very good morning to Honorable Judge, respected lecturer and fellow participant. My name is Hasrul Nazwabi Ahmad Fazil with metric number 19DT23F1046, and today I'm going to present it with my team from Politeknik Muadzam Shah, who will proudly presenting to you our project called VocaLens. VocaLens is smart glasses that turn everyday conversation into live caption, specifically designed for people who deaf or hard of hearing. Our goal is simple: to make communication more natural, inclusive, and accessible without forcing user to look away from the person they are talking to. Now, let's start with the problem. Today, over 466 million people worldwide live with disable hearing loss. Despite this, many existing solutions are still inconvenient. First, most mobile captioning apps require users to look constantly down at their phone, which break eye contact and disrupt natural conversation. Second, in important environments like classroom, clinic, or the public service, communication gaps can reduce learning, engagement, and even quality of care. Lastly, existing smart glasses are often bulk, expensive, and not compatible with prescription glasses, make them impractical for everyday use. So clearly, there is need for a better, more seamless solution. To address this problem, we designed VocaLens with three main objectives. First, we developed a real-time speech-to-text mobile application that converts spoken word into text instantly using the OpenAI Whisper API. Second, we create smart glasses that display caption directly in the user field of view, allowing them to read the subtitle naturally while maintaining the eye contact. And third, we ensure multilingual support, including non-Latin language like Mandarin and Tamil, with translation into Bahasa Melayu or English. These three goals work together to create a full inclusive communication experience. So, what is exactly VocaLens? VocaLens is a wearable smart captioning system that displays subtitle just about an inch from your eyes, almost like watching a real-life subtitle. The system consists of three main components. First, a 3D printed smart glasses module with an ESP32 and OLED display. Second, an Android mobile app built with the Flutter, which captures audio and processes it. Third, cloud service include OpenAI Whisper and MQTT Broker, which handle speech recognition and transmission. Together, these components create one seamless real-time experience. Okay, let's look for how the system is worked. The process starts with the mobile app microphone capture the speech from the environment, and this audio then sent to the cloud, where Whisper platform performs speech recognition and option translation. Next, the processed text is sent back throughout the MQTT broker, which acts as a lightweight communication channel to the ESP32. And finally, the smart glasses receive the text and display it on the OLED screen. All this happens in under 1 second, provide near real-time caption. Now let's talk about the hardware. Our design is clip-on module that can attach to the standard eyewear, including the prescription glasses. It uses ESP32 microcontroller for processing and Wi-Fi connectivity, along with a 0.96-inch OLED display for caption output. The device is powered by the rechargeable LiPo battery, making it portable and practical. More importantly, it is low cost, lightweight, and modular, meaning it is easy to repair and customize. One of the key innovations in VocaLens is a bird-bath optical system. This system allows captions to appear as they are floating in front of the user's eyes while still maintaining a visible of the real world. Here's how it works. The OLED image which pass through a collimator lens to create parallel light ray. Then a beam splitter and mirror reflect the image into the user eye. At some time, ambient light pass through so the user can still see their surroundings. This creates a see-through subtitle experience similar to augmented reality. Okay, now let's talk about application. VocaLens is developed using Flutter on the Android Studio, and it has two main functions, which is transcribe and translate. And transcribe, user can transcribe the voice into the text, while translation mode, user can translate user language into the whatever language user desires. It also has an adjustable font size, which user can choose what size that user wanted in their smart glasses. It also has a static and scrolling display, which user can choose either making the text is static or scrolling on the smart glasses. Okay, now let's compare to the existing solution. VocaLens stand out in several ways. Unlike phone-only app, it provides hands-free eye-level caption. Compared to the commercial smart glasses, it's more affordable, costing under 200 ringgit in component instead of 1000. It also supports multi-language, work with the prescription glasses, and feature an open, repairable design. These make VocaLens both practical and accessible to a wide audience. The impact of VocaLens goes beyond just caption. It enables users to follow conversation in real time, whether it is in lecture, meeting, or daily interaction. It also reduces reliance on interpret in situations like doctor visit, shopping, and public service. More importantly, it promotes independence and inclusion, giving users more confidence in everyday communication. And with cost under 200 ringgit, it is accessible to school, NGOs, and family. Okay. In terms of commercial value, VocaLens has strong potential. It can be used in education for inclusive classroom, in healthcare for better doctor-patient communication, and in the public service to assist frontline staff and user. Because it's low cost, locally manufacturable component, it is scalable and suitable for mass adoption. In conclusion, VocaLens brings conversation back into the line of sight where they belong. It is affordable, practical, and designed to improve real human interaction. We believe this innovation can make a meaningful difference for learners, patients, and community everywhere. Thank you for your attention. Now, we will show you the demonstration of our project. Okay, first thing first, turn on the VocaLens and it will show you the AP mode, which will show you the SSID of the VocaLens and its password. Now, go to your Wi-Fi setting and find the VocaLens setup, then enter the password that have been given from the VocaLens and let it connected. After connect, go to the VocaLens app, to the sidebar and Wi-Fi transfer, enter your Wi-Fi's SSID and password. Be sure to let the Wi-Fi on the 2.4 GHz because microcontroller ESP32 only support 2.4 GHz. After that, hit send to the glasses and you will transfer your credential to the glasses and Wi-Fi will be connected to the smart glasses. Okay, back to the apps, go to the transcription, enable the send to the glasses and start transcription, whatever you want to say, and then click the mic button again to stop it and it will transcribe and it will return the voice to the text as you can see, and it will show the text on the smart glasses. You can also change the font size of the text in the smart glasses or choose the mode, either static or scrolling of the text on the smart glasses. And here's the result of the changes.